Welcome to another explainer here at the Global Issues Daily. Today, we're diving into something absolutely massive. We're taking a serious, comprehensive look at a rapidly shifting global landscape, specifically the staggering scale of modern engineering megaprojects emerging out of China. These aren't just your standard building projects. We're talking about feats that are literally redefining the limits of human capability and infrastructure. It's a monumental technological shift, and it's got profound implications for urban development, the environment, and our global energy structures. So consider this staggering statistic to start us off. Is it genuinely possible to build a towering 204-meter skyscraper from the ground up in literally just 19 days? Now, for decades, conventional engineering wisdom would tell us absolutely not. No way. But as we're going to explore today, the parameters of what's physically and logistically possible are being rewritten right before our eyes. In fact, looking at these rapid advancements, some of the world's leading scientists and engineers are making a pretty bold claim. They're observing that China isn't just 10 or 20 years ahead, but currently 100 years ahead of the rest of the world in the specific field of development and construction intelligence. So, today we're going to impartially look at the data and the actual mega projects on the ground to see exactly how these seemingly impossible barriers are being broken. Okay, let's dive right into this. We'll be structuring our analysis across 6 distinct areas. First, defining gravity and terrain. Second, the speed of modular tech. Third, extreme environment energy. Fourth, relocating history. Fifth, zero pollution construction. And finally, the global impact. Chapter 1, define gravity and terrain. The cloud level bridge. The core challenge of the Wadu-Wujiang Bridge can really be summed up by one massive no: 610 meters. This thing is being constructed at a totally backbreaking altitude. To put that into perspective, if you're standing on the construction site and you look down, the clouds are literally sitting beneath your feet. It's wild. At this extreme altitude, deploying traditional heavy cranes or conventional machinery is completely impossible. Honestly, in most places around the world, this is where a project would just be abandoned. So how exactly do you solve an impossible logistics problem? Well, you invent a completely new system. Engineers deployed the world's largest string crane system. Instead of traditional heavy machinery, these cranes pull on incredibly strong, thin steel wires suspended way up in the air. And these wires successfully lift steel segments weighing up to 21,000 tons. The margin for error here is literally zero. I mean, one slight mistake in a 21,000-ton piece of steel causes catastrophic destruction hundreds of meters below. So to make sure they get millimeter-level accuracy during alignment, the whole operation is guided perfectly by the Beidou satellite navigation system. And this brilliantly illustrates the leap from traditional construction to modern intelligence. This bridge is integrated with an Internet of Things nervous system, so it's not just a static structure. It self-monitors structural pressure, it instantly identifies if any cables are coming loose, and it flags environmental risks in real time. It basically transforms the bridge from a standard piece of infrastructure into a living, breathing machine that's constantly diagnosing its own health. Chapter 2, the speed of modular tech, 3D printing, and prefabrication. Let's compare two completely different methodologies for a second. Traditional construction requires years of on-site building, super heavy manual labor, and let's face it, is always plagued by unpredictable delays. The alternative is the method used to build the mini Sky City Tower. That's the building we mentioned right at the start. It took just 19 days to assemble. 19 days! How's that possible? Well, because it wasn't built brick by brick on site. It was constructed using a modular system. Entire sections were pre-built in a factory, making it essentially a factory-manufactured city. And despite this incredible speed, the structure is designed to withstand a massive 9.0 magnitude earthquake, actually surpassing the safety capabilities of most traditional buildings. The company behind this is even planning a 220-story tower using this exact same method. Now, this unprecedented speed extends way beyond skyscrapers. Check this out, a massive 5,520 square meter park built entirely by 3D printing technology, completely finished in just 2.5 months. There were no traditional hammers, no standard bricklayers, just massive machines methodically printing out an entire urban landscape at a fraction of the usual cost. What's wild about this site is the sheer level of detail. These 3D printers created everything using strong concrete materials. We're talking the walls, the seating areas, intricate sculptures, statues, even the detailed flower pots. But perhaps the most striking part is the aesthetic. Rather than relying on rigid, traditional straight lines, the park features this really fluid, water-like architectural design. It's essentially an art-like structure that actively forces you to stop and question if it was even made by human hands at all. Chapter 3. Extreme Environment Energy. The Kila Power Station. First off, let's clearly define what a hybrid power station actually is. It's a power generation complex that combines solar panel technology with hydroelectric turbines. The main goal here is sheer reliability. It ensures a continuous, completely uninterrupted energy output, regardless of whether the sun is shining brightly or if there's heavy rain falling. The data reveals exactly why the Kila station is such a global engineering landmark. It's built in this incredibly harsh, mountainous environment where temperatures regularly plummet to a lethal minus 30 degrees Celsius, and where high-altitude winds literally make standard machinery fail. To conquer this, engineers built a massive 158 million square meter integrated complex. To put that into perspective, that's an area large enough to fit several small cities inside it. By synchronizing the solar and hydro systems in this totally punishing terrain, they're successfully generating over a gigawatt of pure, renewable energy. This is a definitive, major technological strike against our modern energy crisis. Chapter 4. Relocating History. The 8,270-ton Lai Complex. 8,270 tons. That figure represents the absolutely immense weight of the historic Lijuan complex. Now, city planners needed to construct a massive underground shopping center and a new metro network directly beneath this site. In almost any other global city, an old building blocking a major transit artery like that would just be demolished and eventually replaced. But the decision here was different. They chose to preserve history without halting progress. Now, what's really interesting here is the sheer surrealism of how they actually pulled this off. Engineers excavated completely beneath the massive complex and installed a network of automated hydraulic walking cranes. And these machines didn't just lift the building up, they physically carried it, step by step, almost mimicking the walking motion of a living creature. They slowly marched this 8,270-ton piece of history out of the way, allowed the underground metro construction to finish up, and then walked the entire building back to its exact original location, completely intact. Seriously, it's like science fiction made reality. Chapter 5. Zero Pollution Construction, the Inflatable Dome System. If you live in a modern city, you definitely know the pain of standard construction, right? The constant roar of machinery, that thick dust coating nearby streets, and the heavy exhaust filling the air. Well, contrast that with the inflatable dome method. Before major construction even begins, a massive, visually transparent air dome is inflated, completely encapsulating the entire site. From the outside, it basically looks like a giant clear balloon. And the result? A workspace that's perfectly sealed and remarkably silent to the surrounding neighborhood. The internal mechanics of this dome are entirely focused on environmental protection. It effectively traps all that harsh noise from the heavy machinery right inside. Not a single particle of dust can escape into the city's atmosphere. Furthermore, the dome features an advanced internal air filtering system that actively absorbs the exhaust generated by the construction equipment. It purifies it before outputting completely clean air back into the city. It essentially treats the act of building as a clean, highly controlled process, rather than a dirty, disruptive one. Chapter 6. Global Impact. Solutions for the Future. So the crucial point we really want to highlight is this. What we're witnessing here is a true paradigm shift. We're no longer just looking at the construction of static, lifeless structures. We're looking at the transformation of infrastructure into living machines equipped with real digital nervous systems. And more importantly, we're seeing major global crises, whether it's the urgent demand for clean energy, the need for rapid urban housing, or the massive disruption of city pollution, being aggressively treated with bold, technological innovation. To synthesize the key takeaways from our analysis today, advanced automation and satellite guidance are actively replacing incredibly dangerous high-altitude manual labor. Modular prefabrication and 3D printing are unlocking speeds of assembly we previously thought were totally impossible. Massive hybrid solar agrosystems are securing continuous renewable energy in some of the most unforgiving climates on Earth. And cutting-edge hydraulic technology is proving that rapid modern development absolutely doesn't require the destruction of our historical integrity. We want to leave you with this final thought. As populations surge and the demand for sustainable infrastructure peaks globally, how might these rapid, zero-pollution engineering methods solve critical infrastructure crises in your own country? We'd love for you to analyze the data, consider the possibilities, and share your perspective in the comments below. And hey, if you value this level of in-depth, analytical reporting on the forces shaping our world, make sure to like this explainer and subscribe to the Global Issues Daily. Thank you so much for joining us, and we'll see you in the next analysis.